So I want to dive a little bit deeper into how you guys are using some of that now. So a client comes to you, and let's imagine that you've worked with them, and now you've been able to kind of distill all of their requirements into some kind of more formal setting, right? So you say, okay, these have to be the temperatures, this has to be the texture, and I imagine each one of these things is sort of tethered to something quite quantitative, right? Or measurable. And then you go through you have a database. You're trying to identify candidate proteins. What does the machine learning look like here? What are we talking about?
Yeah. So there's a lot I cannot talk about. Some I can talk about,
Yeah.
which is the paper essence.
Yeah. So this paper is this is a contribution that you guys have made to the community. And I don't know whether that's similar to how you guys are doing it in-house, but we'll be able to talk about that as a process.
I think it has some good amount of overlap, enough to kind of get a good understanding of how things will work in a production level. And in that case, we're talking about regression or classification of proteins or label propagation. So we have in-house experiments that label proteins. And some customer come and they want a protein that has a combination of label, right? We do not have it, or if we already have label, it's great. Unlikely, but great. If their specification falls into a range of something that we don't have, then we have to look for the predicted values, and that's where we use models from a protein sequence predict some features of interest. I mean, some labels of interest.
In the paper, you give the example of localization.
Exactly, yeah. In the paper, we focus on a public data set called, that is used in the paper DeepLock2. So it's a public data set that,
I think I have this.
that focuses on localization, so cellular localization. So the protein, once it has expressed, once it exists within the cell, travels within the cell or outside of the cell, and where it ends up is called the subcellular localization. And knowing where a protein is going to end up can be very useful because, again, for production, you might not want the protein to end up in some part of the cells for scalability. Knowing where it ends up in the cell also allows you to infer some of its characteristics. So it's a quite useful task to be able to do, and there is a public data set, so it's very
that helps.
nice to write.
Oh, I see. So okay, so you're using where it ends up, sort of like the destination within the cell, as some marker or some attribute of the protein. And that attribute can then tell you, or perhaps correlate with other things that you might actually care about from like a business perspective.
Right.
So customers care about X. You don't yet have information about X, but you have information about Y, and Y here being like where exactly it ends up in the cell. But there is some type of relationship between X and Y.
Exactly. Yeah. It's unless a customer wants proteins that end up at a specific location in the cell, which is unlikely. It's more like being in. For example, I think we can take the example of being predicted to cross the cell membrane, so to be an extracellular protein can have some significant advantage for being produced in a large scale production. So if you can predict that the likelihood of a protein or given sequence to actually be labeled extracellular allows you to really sort your candidates in a more informed way.
Yeah, that's very cool. Okay, so just while we're still on this topic, uh, subcellular localization. So where can it end up in the cell? What do we like? What are the possible destinations?
Yeah, so I think there's 8 labels, so there's probably uh, more in the paper. But if you, sorry, there's more in reality. But if you look at in the paper, we end up with things like I think we made a result table,
Oh yeah.
which are the cytoplasm, the nucleus, the cell membrane, the mitochondrion, and
Oh yeah, here.
those are the at least the one we're interested in.
Yeah.
Uh, and those are just positioned in the cell. Again, we use this as a more like a downstream benchmark task to show that this method could be applied to any labels, and
Yeah.
in reality, you would not necessarily have those labels. You could have like other labels, but the method would stay the same. So this paper, which is nice about this paper, is that you could fully change the data set. We can expect the result to be similar.